Hi, welcome to Moo Moo Math. Today we are proving double angle formulas, evaluating double angle formulas, solving double angle formulas, and simplifying identities. Okay, I've already done the first video on proving. Now we're going to evaluate. So let's look at this part 2, evaluating double angles. Well, first of all, I need to show you that the sine of 60, because we know that one's on the unit circle, what it is and what it's not. Okay, first of all, the sine of a double angle, in other words, 2 times u, is not equal to 2 times sine of u. So you can't factor this 2 out and put it in front. But indeed, the sine of this double angle is equal to 2 times the sine of u times the cosine of u. So first we're going to take one that we know. So we're going to use 60 as our example. Okay, we know that the sine of 2 times 30, well, 2 times 30, that's the angle 60. Well, what's the sine of 60? Well, you have to think about your unit circle. So let's think about the xy axis, and the sine of 60 is right here. And we know the sine of 60 is the y coordinate, which is the square root of 3 all over 2. It is the height in this position of your 30, 60, 90. So how does that compare to this formula? If they are the same, then this other one should be the square root of 3 over 2. But I'm going to show you that it's not. So we're going to take the sine of 2 times the angle 30 and write it as the formula says, 2 times the sine of 30 cosine 30. So now we need to think of the half of that angle in its position. Well, 30 is right here. And we know the sine is a half at that position. So sine of 30 is a half, and then we're going to have 2 times that 1/2 times the cosine at that position. Well, the cosine at that position is the longer side of the 30, 60, 90, which is the square root of 3 over 2. So what all does this simplify to? Well, the 2 times 1/2 cancels out, and it ends up being the square root of 3 over 2. So that is true. We know this formula does indeed work. So how does that compare to 2 times the sine of 30? What if we factored that out? Well, let's go back and look. What is the sine of 30? That's this position. That's a half. So 2 times 1/2 is just 1. And we know the sine of 60 does not equal to 1. They're not equal. Therefore, this formula does indeed hold true, and the sine of 60 is equal to the formula versus 2. You can't factor this 2 out. I've just shown you those 2 are not equal. Okay, so let's evaluate cosine of 2u. We're going to use cosine squared minus sine squared. This one has more than one form, but that's the one we're going to use. Okay, so we have cosine of 2 pi thirds. Well, we know the answer to that, so we can kind of plot it out before we even start and look at what it should be. Okay, 2 pi thirds is in quadrant 2, and cosine is your x direction, which is negative 1/2. So our answer should be negative 1/2 when we expand this. So when we expand it, let's rewrite it with the angle written as a half angle. So I'm going to rewrite cosine of 2 pi thirds is cosine of pi thirds. We don't have to do that. Hang on. We're going to use our formula and just take the cosine of half of this angle. So what are we doing? We're going to take cosine of just pi thirds, which is half of the angle, and we're going to take that quantity and we're going to square it. And we're going to subtract from it the sine of pi thirds, which is half of the double angle, And we're going to square that, and then we're going to subtract them. So there we go. We're going to expand that as half of this angle, which is, remember, 2 pi thirds, can be written as pi thirds plus pi thirds. Okay, so we're just taking half, oops, should be a 3, should be just half of the original angle. Now, 2 pi thirds is right here. Well, cosine in that position is just 1/2. So I'm going to take 1/2 and I'm going to square it. I'm going to subtract from it sine of pi thirds. Well, sine of pi thirds is √3 over 2, and then I have to square that one. So once I square these, 1/2 squared is 1/4. And then √3 over 2, I've got to subtract that, and that's going to give me √3 squared is just 3. And then 2 squared is 4. So 1/4 minus 3/4, that's -2/4. And what do we know -2/4 is equal to? -1/2. Well, there you go. I just showed you that this formula does indeed work. Because this position is on the unit circle, I can show you that it works. Not all of them are going to fall on the unit circle, and that's why you have a double angle. So let's evaluate sine of pi halves using a double angle formula. So using the double angle formula, I've got to figure out what's half of pi halves. Well, half of pi halves is pi fourths. So if I divide this by 2, which is also multiplying by half, I'm going to work with the angle pi fourths in my equation. So rewrite the angle as a double angle. So it's just pi fourths. So sine of pi halves, we know what that is. That one's on the unit circle. But to prove it, let's plug it in as 2 times sine of the half angle, which is pi fourths, times cosine of pi fourths. Well, let's see. We're going to bring down the 2, and then sine at pi fourths is √2 over 2 times cosine at pi fourths. That is also a √2 over 2. So when I go and multiply these together, these 2's cancel, and then I have √2 times √2, which is √4, which is just 2. And then I have 2, and all over 2. Well, that's just 1. And don't we know that the sine at pi halves is indeed 1? So there you go. There's one to prove to you that this works on the unit circle. Okay, let's try tangent of pi thirds. Well, what's half of pi thirds? You have to think through what half of that is. Well, half of pi thirds is pi sixths. So we're going to use pi sixths to work with it, okay? So let's rewrite this with half the angle in here. So tangent of pi thirds is equal to 2 times tangent of pi sixths all over 1 minus tangent of pi sixths. Now, what's tangent at pi sixths? Let's think about the unit circle. Okay, unit circle, we are right here, and that would be a √3 all over 3 for tangent. So let's plug in a √3 over 3 here and here. Oop, I forgot my square right there, didn't I? Okay, don't forget to square this bottom. So we have 2 times √3 all over 3 all over 1 minus √3 over 3, and then don't forget the square. Okay, so let's see what we have. In the numerator, we have 2 √3 over 3, and in the denominator, we have 1 minus, and let's square this thing. The square root of 3 squared is just 3. The square root of 3, or 3 squared is 9. So that gives me 1 minus 3/9, which is 1/3. Well, 1/3 is just 1 minus 1/3 is 2/3. So my denominator is 2/3. My numerator is 2 root 3 over 3. So when you have a complex fraction, we're going to use that to keep, change, flip. So keep the first one, multiply, and then multiply by the reciprocal. And boom. So what's our final answer? Our final answer is the square root of 3. So that is what the tangent of pi-thirds is, using the double angle formula. So there's your third one. Okay, let's try a double angle using triangles. So we're going to start with sine x being 3/5 in quadrant 2. Okay, quadrant 2 is important because sine is positive in quadrant 2, but cosine is negative and tangent is negative. So the first thing you want to do with these is you want to draw your picture so you can see it. So let me take this off. And here we are in quadrant 2 with the triangle and the reference angle of x with a sine of 3/5. Now, we want to find the sine, or the sine of double this angle x. Well, this angle x, if I double it, it's going to end up way over here somewhere. Okay? It's going to either be in quadrant 3 or 4. I'm not sure exactly where, but it's going to be a larger angle. So what I have to do is I have to think about first writing the formula down. So the sine of 2x is equal to the sine, or 2 times the sine of x times the cosine of x. Oh, I don't know why it did that, but it jumped on me. Let's fix that. Times the cosine of x. So what I'm doing is I'm taking a double angle down to a single angle, and this is a single angle because that's what my triangle is drawn with, the single angles. So to evaluate the sine of 2x, I'm going to take 2 times the sine of x. Well, that was given to us as 3/5. And then cosine of x in quadrant 2, that's negative 4/5. So I have a 3/5 and a negative 2/5 as my two trig values. So now let's just multiply all these together. 2 times 3 is 6. 6 times negative 4 is negative 24. And then in our denominator, we just have 5 times 5. So there we go. It's negative 24/25 to evaluate the sine somewhere over here. And that makes sense. It should be negative because if it's from quadrant 3 or 4, don't we know sine is negative down here? So there you go. So now let's look at cosine. Okay, cosine of the double angle, I can use any of my formulas. I can use the sine formula, the squared formulas. I can use cosine squared minus sine squared, or I can use that 1 minus 2 sine squared. I'm just going to go ahead for the first time. I'm going to go ahead and use cosine squared x minus sine squared x. I already have my sine, so it's nice and easy. I've already got the triangle drawn. So I'm just going to use the two trig functions from our triangle. So our cosine was negative 4/5. I'm going to take that and I'm going to square it. And I'm going to subtract from it the sine, which was given as 3/5. Now, when we calculate this, that's going to give us 16/25 minus 9. Whoops, I forgot my squared there. Minus 9/25. And that's going to give us 16 minus 9 is what? 7/25. And there is our final answer. Okay, there's our second value. Now let's evaluate the double angle. Let's talk about the sine of this for a second. Okay, cosine in this problem ended up being a positive value. So what does that tell us about which quadrant it ended up in? Okay, it's a negative sign, but it's a positive cosine. So that must mean this double angle is actually in quadrant 4, and that's how you can tell. Okay, now tangent, we're going to use our tangent formula. We're going to do 2 times the tangent of x, and then minus 1 times tangent squared of x. Now we haven't written the tangent yet, so let's go back, look at our triangle, and see what the tangent is. Okay, tangent is going to be opposite, which is 3, over adjacent, which is negative 4, so negative 3/4. So it's going to be 2 times negative 3/4 all over 1 minus the quantity negative 3/4 squared. And I say quantity because you have to be careful, you're squaring that negative value. So the product is on top, so let's see. This would be 2 over 1, and the 2 is going to cancel with a 4. So our numerator is negative 3/2. And our denominator is going to be 1 minus, and then that's going to square and become a positive. So that's going to be 9/16. So 1 minus 9/16, we're going to write this as 16/16 because that's 1 minus 9/16. So that's 7/16. Then we have a complex fraction. So we rewrite this as 3/2 times 16 over 7. So what's that going to give us? Let's do a little reducing here. The 2 goes into the 16, 8. So that gives us negative 24 over 7. And there we go. We've got the tangent of that same angle. So I hope you see kind of a common theme here. Negative 24/25 was a sine. The cosine was 7/25. And then the tangent was negative 24/7. So what are we dealing with? We're actually dealing with an angle that is in quadrant 4, a reference angle, where the hypotenuse is 25. The opposite is a negative 24, and the adjacent is 7. So really, this is the triangle we were working with. Isn't that cool? So a 7, 24, 25, half, if we take half of that, it ends up being a 3, 4, 5 triangle in quadrant 2, which I think is pretty cool. Okay, so let's look at one more example of this type of cofunction, or this type of evaluating. You're going to do this with secant. Now, secant's not one of our 3 main trig functions. It's a cofunction, so you have to work with it a little bit more. So we've got secant u is negative 7/2, and we're in quadrant pi halves to pi. That means we're in quadrant 2. So we know this is pi halves, and we know this is pi. So we're in quadrant 2, so let's draw our secant triangle. Now secant is hypotenuse over adjacent. So 7 is your hypotenuse. The adjacent would be negative 2. Now to find the third side, we're going to use the Pythagorean theorem. I'll call this for now, we'll call it y for the y value. So negative 2 quantity squared plus y squared is equal to 7 squared. So we end up with y squared is equal to 49 minus 4. So y ends up being the square root, plus or minus, the square root of 45, which ends up being 3, what's that going to be? 3 roots 45 is 3 root 5. Now we have to decide based on the quadrant if it's a positive or it's a negative. So since we're in quadrant 2 and it's the y direction, it's going to be the positive 3 root 5, not the negative 3 root 5. So there's our triangle. Now working with those, I can do my sine, my cosine, and my tangent formula. So the sine of the double angle 2u is going to be 2 times the sine of u, which is the single angle, times the cosine of u. So let's figure this one out. So we have 2 times, well, the sine of u is 3 root 5 all over 7. We're going to take that times the cosine of the angle, and I'll go ahead and put u. I should have put u in there. Okay, now cosine is just the reciprocal of secant, so that's just -2/7. And so let's see what that gives us. That gives us 6 times -2, which is -12 over root 5 all over 7 times 7, which is 49. So there is the sine of the double angle, okay? Then we can find the cosine. Now this time on cosine, instead of using the double angle cosine squared minus sine squared, I'm going to use, let's do 2 cosine squared u minus 1. We're going to use this time just a different form. So let's see, we've already figured out the cosine. Cosine was kind of given to us because secant was given to us. So we just take the reciprocal. So 2 times cosine is -2/7. And we got to square that though. So don't forget to square that, minus 1. So -2/7 squared would be 2 times the quantity, +4 over 49 minus 1. But I'm going to write my minus 1 with a denominator of 49. So that's just going to be 49/49. So let's see, that gives us 8 on top, right? 8 minus 49, which is -41 over 49. And there is my cosine of my double angle. Okay, now let's try the tangent. The tangent is equal to 2, or the tangent of 2u is the tangent of u, the single angle, which is what we have, 1 minus tangent squared. Now, I'm going to stop here for a second because I don't know if you've kind of put this together yet, but this is going to be a lot of work. I already know my opposite and my hypotenuse, and I know my adjacent and my hypotenuse. So can't I just draw this triangle? I sure can. So knowing that sine is negative, cosine is negative, that means my tangent must be positive. So I must be in quadrant 3. So let's draw this triangle in quadrant 3. And this is the double U angle. Okay, I know that my adjacent is going to be -41. My opposite is going to be -12 root 5. And I know my hypotenuse is 49. So I can actually draw that triangle, and it makes my my double angle for tangent easy because I'm just going to write sine over cosine. So -12 root 5 all over -41, which just becomes +12 root 5 all over 41. Now, I could work the problem out and get the same answer. And this makes sense because I have sine and cosine are negative, so tangent's going to be positive. I could plug in the tangent and work it all out of the single angle. But now that you've got enough information about the double angle triangle, you have adjacent, hypotenuse, and opposite, you can actually just draw it. So this one ended up being in quadrant 3. So let's talk about that for a second. Quadrants, okay? So anytime you have a double angle in quadrant 2, If you half it, it's going to end up in quadrant 1 because 90 to 180 are all the angles in quadrant 2. So if you take half of that, half of 180 is 90, and half of 90 is 45. So they're going to happen in the second half of quadrant 1. Now, if I take a double angle from quadrant 3, so I'm going from 180 to 270. Well, 180 starts here at 90, and half of 270 is 135. So that means any angle that's in quadrant 3, when I take a half of it, using the half angle, it's going to be in quadrant 2, but in the first half of quadrant 2. Then all the angles from 270 to 360, which occur in quadrant 4, half angles, well, half of 270 is 135, so that means all the half angles in quadrant 4 start in quadrant 2 halfway, and half of 360 is 180, so they're going to be in the second half of quadrant 2. So you can kind of use that to help guide you through signs to make sure they're correct. So there we go. That's the end of using the double angle formulas to evaluate. The next video will be on solving. I hope this video was helpful.